Let's take a look at question 17 from the module 11.1 homework. Keep in mind with any of these, numbers are going to be randomized, so you're going to end up with a slightly different problem when you attempt to work on each of these. But in this problem, we've got an automobile company that's ready to introduce a new line of cars. After test marketing the line in a carefully selected city, marketing research estimates the sales will increase at a monthly rate of S prime of t. So this is the derivative of our sales function. So we want to find the sales function, S of t, when we know that at the beginning of the campaign, there were no sales. So we've already got the answers mapped out here, but let's go ahead and take a look at how we would arrive at each of these results. So in part A, we want to find S of t, which is the indefinite integral of S prime of t, dt, which means we want the integral of 13 minus 13e to the negative 0.1t dt. Now, a formula that I've introduced and is one that we're certainly welcome to use from this point on, we could apply integration by substitution to solve this, or we have this identity which ends up always being true, that the integral of e to the ax dx is equal to 1 over a times e to the ax plus c. So the reason we kind of establish that property is just because we get the integral of some constant times x occurring frequently. And rather than having to go through the steps of integration, we can pick up on this pattern and apply this as a quicker route. So our integral here will be 13t plus 13 over 0.1. I'm sorry, that should be minus 13 over negative 0.1 e to the negative 0.1t plus some constant c, or if we just simplify here, minus a negative becomes plus 13 over 0.1 e to the negative 0.1t plus some constant c. And then we could simplify 13 over 0.1, that's just going to be 130. So this is our indefinite integral, but we want the complete function S of t, so we need to figure out what that value is for c in this case. So we're told that at the beginning of the campaign, so that would be when time equals 0, then this function evaluated at 0 So at the beginning of the campaign, there were 0 sales. So when we evaluate this at time t equals 0, our result should be 0. So 13 times 0 will be 0. 130 times e to the 0 will be 130. Plus some constant c, which implies c has to be equal to negative 130. So our complete sales function is going to be 13t plus 130 e to the negative 0.1t minus 130. So anytime we're calculating an indefinite integral and we have some constant at the end, if we're trying to get that original function, then there's usually some information given to us in the problem so that we can substitute and solve for c. So in this case, if we assume no sales at the beginning of the campaign, implies that when t equals 0, then our sales function also has to equal 0, and then we can solve for that constant. So in part B, we're asked what are the estimated total sales for the first 12 months of the campaign. So this would just be taking our sales function and evaluating it at 12, which would give us about 65.16 or about 65, rounded to the nearest whole number. And then in part C, we're asked when will the estimated total sales reach $90 million? Use a graphing calculator to approximate the solution to the equation S of t equals 90. So we can type in our equation, 13x plus 130. I don't need that parenthesis there. So 130 times e to the negative 0.1x minus 130. We can go ahead and graph that function, and I've already set up the view of my window here to be x from negative 2 to 15, y from, I think actually the calculator set that one up, but from about 3 to 95. And now we can use the calculator to estimate when our function value is 95 by hitting the trace button and then just moving along the graph. And we're looking for when this should equal 90. So we get about 90 here, and here we get about 14.6, which matches up with that approximate answer they came up with. So here x is obviously our x value, y is our function value. So we're trying to figure out when is our function value equal to 90 or approximately equal to 90, so that's pretty close. And we get, again, that value of about 14.6.